Cool. Thank you, sir. Yeah. Okay. Well, thanks for the intro. So we're supposed to talk about toys today, and I'm going to talk about a very specific type of what some people might call toy, but I'm going to talk about something a little bit different, and that is we're really going to talk about robots with character, because I'm going to try to convince you that the future of toys lies very much within physical robots with actual intelligence combined with things like animation and gameplay. And I want to tell you a little bit about what we're doing at Anki, and I'm going to use a few products we released so far. Some of them have been in the market for a little bit, and some of them are new, to show you examples of where we think the future of toys is going, and it's somewhat intertwined with the future of robotics and character, and how those things have been working so far for us, and what we learned along the way, because a lot of things were completely non-obvious to us, and over the last 6 years, there were a lot of learnings we had, and I want to share some of those with you guys today. So just a little bit of background. My co-founders and I, we met at the Carnegie Mellon Robotics Institute doing our PhDs there. And we worked with usually very large, expensive robotic systems. A lot of that work was sponsored by the military. It was autonomous vehicles. It was my work was a lot in remote bomb disposal, for example. So really big robotic systems, but very, very cool stuff. And while we were in grad school, we decided we want to try to figure out how to get some of those things which we see on a daily basis in research labs, but get it into consumer products, something anybody can go and buy in a store for just a few $100s, because we very much believe that we can use those same technologies we were using in research labs, but make consumer products better. And we decided that the first industry we're going to go into is entertainment. And the thought process behind that was that we looked at physical toys and how they developed over the last, let's say, 30 years. And we compared that to video games and looked at how those developed over the last 30 years. And if you think of the very first video game you can remember, I don't know how many guys of you know Pong. It's one of the very, very early video games. Good. And you compare that to video games today, they have almost nothing in common with each other. But if you look at physical toys from 30 years ago and you compare them to physical toys today, there's a little bit of electronics here and there, but the play patterns, the way how you fundamentally use them, have not changed. And that discrepancy to us felt like, okay, there is a real opportunity there, and we wanted to try to figure out whether we can use robotics and AI to take some of the things we love the most about video games and put them into, I guess, into real physical entertainment. And so the first thing we did is we started with a product called Drive, and that then developed in the second generation, Overdrive. It's a racing game where you play with physical real cars. And I won't go into too much detail here, but the premise is really that we're taking elements we love the most about video games. For example, that you can compete against opponents which are not controlled by humans, but they're fully self-driving cars. That you can get better over time, and the game will adjust to that and gets better over time as well. And so we get people who play with something like this significantly longer than what they would play with something where the game or toy you buy today is the same thing tomorrow and in 3 days from now and in 4 days from now. So the way how this worked is the product's doing super well. We have by now 3.4 million hours of gameplay logged. The cars, which are small, they're about this size if you haven't seen them yet, have driven a total of 2.3 million miles right now. That's about 10 times to the moon. And the racetracks are reconfigurable, and we logged 60,000 unique track configurations across the world so far. So this is working very well, and people heavily make use of video game elements. And I want to show you a little bit how we develop something like this and why we think it's important and where it works and where it doesn't work. But I'm going to use actually our second product as the main example today. It's called Cosmo. I don't know how many of you guys have seen it. It just came out a few months ago. It's a small robot, and the idea for Cosmo was that when we watch movies which have robots in them, animated or not animated, movie characters such as WALL-E, R2-D2, there's an old movie called Short Circuit with a robot in it called Johnny Five. Sounds like you guys know that movie too. It turns out that when you watch movies like that, behind every single character like that, there is a huge character team sitting behind the scenes, planning in minute detail how that robot is supposed to behave in that movie. And that makes us fall in love with characters like this. But when you compare that to robots in the real world, that's not how the real world works. Most robots in the real world are either utilities, or there are a few engineers who decide, wouldn't it be cute if our robot has a face or something like that, or we make a little animated mouth. And we felt very much what we need to do is we want to create a real physical incarnation of a robot, which you normally only see in movies. And the two key components in here were the robotics on one side, which I'll show you in a little bit, and then animation and character on the other side, where we essentially created an animation studio with people in the company who came from backgrounds like Pixar and so forth, who really plan out in minute detail how this robot should behave. Let's see what I can skip over. Somehow the clicker doesn't work. Let's see, I'll use this. So just to give you an idea, this is Cosmo. If you haven't seen it, you can come up here afterwards and check it out. Cosmo didn't always look the way it looks right now. This is sort of an overview. Over the last 4 years, we went through 44 different, fundamentally different iterations. The top left was the very, very first design after we told engineering approximately what we want. They came back and thought we're essentially done. And then the designers looked at it and said, yeah, probably not. And so 44 versions later, we arrived at the final version here. And then to show you a little bit on what's on the inside of Cosmo. So an overdrive car, which is very, very complex already, is made out of approximately 27 parts. Cosmo is made out of over 360 parts. And that is necessary to really bring all the elements of the character out. And I'll show you a short video one of our engineers created. Let's see, yep, audio is working, of a build-up of what's inside of Cosmo. So Cosmo has 4 motors in it. There's a lot of gears and so forth. There are 4 different circuit boards with a lot of electronics in it. Cosmo has 3 different processors on the inside, all responsible for different areas of the behavior. And then in the head, which is going to pop up in a little bit, there's the main electronics actually sits in the head with the main processor, a camera, and an OLED display, which we use to render the face. And you'll see in a little bit how this works. But really, all the technology on the inside, I get excited about it, but people who play with the robot, in a lot of cases, don't really care. But the tech is necessary to make a character like this work. So I'm going to show you a few videos because it's too many people here to do a live demo. But I'll show you a few videos which we normally don't share. So you'll see some older prototypes in here of what Cosmo does and how he behaves. And then we'll talk a little bit about the importance of character here. So this is Cosmo sitting in his charger when he does nothing, except that it's not really nothing, but he's snoring. And all the details here on how he behaves are animated by our animators. And so he's in the process of waking up right now. So he's going to decide to come off the charger in just a bit. So now he woke up, and now he's looking around and he's looking for interesting stuff. And interesting could be anything. In this case, you're going to see in a little bit, he will see a hand. Let's see here. So he notices something is moving. He doesn't know what it is, but he knows something is moving. So he gets excited about that and is trying to check it out. And then he will do things which are in some cases unpredictable. So Cosmo's goal is to have fun and to play, and there are basic interactions like this, like pouncing on things, being interested in things and so forth, which he does. Then he reacts to all kinds of external input triggers. For example, it turns out a lot of people take the poor guy and flip him on his backpack. And so you'll see here one of the versions of what happens if you do that. So all kinds of input triggers like this are happening in the robot. So there are literally hundreds of different things the robot can react to. Now, a cute character is not enough. You actually need to figure out what are people going to do on a daily basis with this robot. Now, how are they going to be engaged for a long period of time? And that's where gameplay comes in. So in addition to basic interactions like this, there are actual games you can play with Cosmo. And I'm going to show you 2 early versions of 2 games, one called Speed Tap, the other one called Cube Slap. So this is a video just taken with an iPhone. So sorry for the quality, and there's some language in there when I lose a game, so I'm sorry for that. The way the game works is whenever those two cubes light up in the same color, each player has to tap their cube, and whoever does it faster gets a point.
I wonder if we can add some of the fake out logic here.
Yeah.
Oh, yeah,
Are we
I
not-
made 3 different animations. Also, if we wanted to modify...
So sorry. So the robot's really good at this, much better than any player. So we actually need to dial this down. This is another game called Cube Slap. It's sort of like hand slapping. So as you move the cube closer, the robot's going to try to go after it, and you need to try to pull out the cube.
That was not a fake out.
Too quick. It's too quick.
How does he decide to do the fake out?
It's random.
Yeah, it's just random.
Okay, let's try one more time.
Dude.
So those are 2 examples of games, and in the app there are multiple ones, and we as a company are releasing new ones over time. That's how we're creating additional content, which is important to keep people engaged in the game. Now, on the background, there's a huge amount of technology necessary to make all this happen. And I show you a few examples of this. Computer vision is one of them. So Cosmo has a camera in its mouth, and it's the entire time the camera is looking at things, and the robot's trying to figure out what's happening around him. And that is super important. If he doesn't know where you are, if he doesn't know who you are, then he's not going to be a believable character. So in this video here, you see, this is an actual capture from the robot's camera. So the robot is tracking people. He's recognizing them if he has seen them before. And in addition to that, he looks for facial expressions. Are you happy right now? Are you sad right now? Are you angry with me? Are you looking at me or somewhere else? So all those things are happening in the background. In addition to the computer vision, there's something we call the personality engine. And that is the core of the robot's personality. And the key here is that in order for the robot to not be completely predictable, this is not just a big if-then-else statement, but the personality engine has certain parameters like happiness, braveness, confidence, social interaction, which are changing in real time the entire time based on anything which happens to the robot, whether he wins a game, loses a game, and I'll show you how this works. So this is a back-end tool just for the company internally. What you'll see in a second here on the bottom left is this is the robot's camera view, and he's going to drive forward and reach the edge of the table, and his computer vision system missed the fact that there is an edge, and he will hit the edge of the table and then figure it out at the last second. And then what happens here is there's this cliff react action and this white curve drop down, and that is braveness. So what that means is he got scared because he saw the edge, and so his braveness dropped. The second example, he will try to pick up one of his cubes, and he succeeds doing that, which makes his confidence go up. So all of those things, how many times he loses in a row, how many times he wins, whether he sees a lot of people or whether somebody's neglecting him and he hasn't seen people in a while, all those things change his personality and his mood, and that influences his future behavior. And that is the core of how the system works, and it makes him feel much more like a pet and not a toy. And then I'll show you an extreme example. This actually happens if you get a Cosmo. Those kind of things happen, except the last part, because those are still old prototypes. So in this case, the robot played this game Speed Tap against one of our developers. So she was playing Speed Tap against Cosmo, and he lost multiple times in a row, and he got very annoyed by that. And so you'll see what happens after he loses this time. So now the cubes are not supposed to explode, which the real ones don't. But again, those were old prototypes. But those kind of things are animations which our animators created, and the personality engine chooses then out of a library of those animations the best fitting one for the current situation. And now I want to talk a little bit about the character itself, because that is, in addition to the technology, that is the main other component of something like Cosmo. So we literally have posters like this plastered all over our office where our character team is trying to figure out every minute detail of how the robot should react in certain situations, what's in character, what's out of character. Should he be mischievous or should he be loving right now? And so all of that is mapped out and then made into animations, which are then not really just played back on the robot, but they're modified every time so that they're different every time they're being played. So, and this might be interesting for some of the people who are familiar with Autodesk products. Our main animation system is using Autodesk. We're actually using Autodesk Maya, so sort of what everybody uses to make animated films. But we're using it to animate a physical robot. And on the bottom right, you see Keiko, one of our animators. They act out a lot to figure out how the robot's body should move and so forth. But the key here was we wrote a huge amount of software inside of Maya to allow the animators to animate efficiently. And what that means is, in the beginning, they started out with just animating the 3D model, and then after a few hours, when they felt they had a good animation, they would load it onto the robot and then check it out and then see whether it works. And in a lot of cases, that animation behaved very differently on the robot than it would behave on the screen. So what we did instead is we turned that screen partially off, at least the 3D parts here. Every animator has a Cosmo sitting right next to them on the desk. And as they're changing animation curves, in real time, they see the animations being played back on the robot itself. So the robot becomes their display. And that allows them to iterate very, very quickly and create animations with a fidelity which they otherwise couldn't do. So that was one of the key tools we developed. And this is the last slide on the animation side. I just want to point out two things. I mentioned earlier there were a lot of learnings over the last multiple years. And I want to point out two of them because they were very fundamental and very exciting for us. One of them was pupils. So in the beginning, when we started out with the robot's eyes had pupils, like the top left quadrant in this graph here. Pupils turn out to be super important to allow people to understand where the robot's looking at, because our brains are trained to understand other people's pupils, and you know exactly whether somebody's looking me in the eyes or even looking like half a foot next to me. And without pupils, people lose the ability to know where somebody else is looking at. So we really needed them, but the animators hated them because they said it makes the robot look too human. So they went through hundreds of iterations of eyes and then at some point figured out that you can't get rid of the pupils by using a technique in animation known as squash and stretch. And so what they're doing is if you use the right version of that, and if the robot's looking left, let's say one eye becomes a little bigger, the other one gets a little smaller, and vice versa. And if you do that just right, then that allows people to actually understand where the robot's looking at. And so that gave us both. It didn't look too human, but people still understood exactly where the robot's looking at. And the second one, also very important, is eye contact. That's something we completely didn't know in the beginning was important. So the robot will try to make eye contact with you, but in the beginning he did it only when he needed something from you. So let's say he wants to play a game, so he would drive up to you and ask you to play a game, and he would make eye contact with you. Or when he wanted another cube and couldn't find one, then he will drive up to you and ask you to give him another cube. But in between, when he just plays by himself, we call that free play, which he does a lot, then he wouldn't look at people randomly. And the robot started to feel very detached, almost like a hamster or a turtle and less like a dog or a toddler. And we did a lot of research on this, and my co-founder's son, who at that point was 1 year old, we did a lot of experiments with that poor kid. Much more, I think, than his mom wanted us to. But, and then we read a lot of research afterwards about this. And so it turns out a toddler will make eye contact with people around him, even when he doesn't need anything from them, as frequently as every 8 seconds. And if they don't do that, that's one of the earliest signs of autism. And when we read that, we realized, wow, that's exactly how it feels when Cosmo doesn't make eye contact with you. So what we did is we just literally cranked up a parameter, which is the eye contact interval, and it completely changed how people perceive the robot. So something we had no idea about and just learned about on the way, or along the way. So this is the end of this. I think I have like 3 minutes left or so. So I'm just gonna very briefly mention one more thing, and it's the SDK. Might be interesting for some of you guys. So it turns out that in the process of developing Cosmo, we also probably created one of the most sophisticated research robots out there. And you can buy it for essentially very little money compared to other research robots. And we created an SDK, and it's we don't know how big the market for this is yet, but we really care about this, and I want to show you why we care so much about this. There is a huge difference between writing code for an app right now versus writing code for a robot, unless you're a professional roboticist. If you write code for an app, this is approximately what you go through. You start really simple if you don't know how to do it, and then you learn a little more, you make a cooler app, you learn a little more, you make a better app, but it's a very linear experience. If you write code for a robot, this is what you're looking at. You start out very simple as well. You make lights blink, you make robots drive up to a wall and then turn 90 degrees or so, but that's when people usually tap out. And all the other stuff, the stuff which really makes robots cool, facial recognition, path planning, and so forth, are impossible to do unless you're a professional with many years of time. And we realized we had to develop all this stuff up here anyways. So we decided to make it available in an SDK so that it really becomes very simple for people to use. And I'll just show you one example here. This is a video of a program which is 2 lines of code. So what it does is, every time the robot sees a face, he will turn that little light on his backpack blue, and when he doesn't see a face, he will turn it off. So pretty simple. Face, light on, no face, light off. It's a very powerful example, though, because turning on a light and turning it off is very simple. No question there, simple line of code. But checking whether there is a face or not, that is also just 1 line of code in here. And when you call that 1 line of code, that's 9,000 lines approximately of code underneath, which are being fired up to analyze every single pixel in this camera image to figure out where there are faces and how many there are and where they're looking at and so forth. But now you get access to it with 1 line of code, so that suddenly makes something like looking for a face as simple as turning on a light. And so there are hundreds of functions in the Cosmo SDK which allow people to do this kind of stuff. And so just to sum this up, we really fundamentally believe that the future of toys is not actually toys, but instead it's a combination of robotics, character development, and gameplay. And that doesn't mean there are going to be no other toys out there in the future. There will always be low-cost things out there you can buy. But with video games and the kind of things people get used to when they have access to mobile devices all day long, the future of where this whole industry is going to go is going to be very much unlike what we've seen in toys so far, and it's going to have to be significantly heavier on the character side of things, where interacting with something, with a device, in this case with a robot, becomes almost like interacting with a pet. And that is where we as a company, for example, are working on with Cosmo, with future versions of characters like that. But if I had to make a guess where this whole thing is going, this is where it's at. And we're super excited about it because the reactions of people and so forth have been really good, even with just the very first versions of things we released. So that's the end of the talk. And yeah, thank you very much. And I'll be here for questions afterwards if there are any. Thank you.